Ever wondered how your favorite gadget works, or how it became so compact yet so powerful? The answer lies in a tiny component, the transistor. This ubiquitous yet often overlooked component is the unsung hero of our digital age. It's the humble transistor that underpins the functioning of everything from your smartphone to your gaming console. Transistors are the building blocks of modern electronics, serving as the stepping stones to the creation of integrated circuits, which later evolved into the microprocessors powering our devices today. Despite their diminutive size, transistors hold immense power. They control the flow of electrical current and amplify signals, enabling our devices to perform complex tasks at lightning speeds. Imagine, if you will, a world without transistors. No smartphones, no computers, no internet. It's a sobering thought, isn't it? The transistor, in many ways, is the very heartbeat of our digital world. A world without transistors would be a world devoid of the digital revolution we're experiencing today. Our journey begins in the mid-20th century, a time when vacuum tubes ruled the world of electronics. But as innovative and revolutionary as these tubes were, they weren't without their flaws. They were large, consumed a lot of power, and could be unreliable. It was clear that the world of electronics needed something smaller, something more reliable, and above all, something more energy efficient. Enter Bell Laboratories. In the year 1947, a group of their scientists embarked on a mission to create a device that would overcome these limitations. After months of relentless work, they finally made a breakthrough. The result? The transistor. This tiny device, no larger than a grain of rice, was capable of doing the same job as a vacuum tube, but with significantly less power. And so, the transistor was born. This invention was a game changer, marking the beginning of a new era in technology. So, how does this tiny powerhouse function? It's simpler than you might think. Let's start by understanding that a transistor is made up of three parts: the emitter, the base, and the collector. These aren't just fancy names. They each have a specific role to play in the grand scheme of things. Picture the emitter as the starting point of our journey. It's the part of the transistor that, well, emits. It sends out electrons or holes, depending on whether we're dealing with an NPN or a PNP transistor. But let's not get too technical here. For now, just remember that the emitter is like a busy train station, constantly sending out passengers into the wild. Next up is the base. Think of it as the gatekeeper. It's extremely thin, and it decides how many of the emitter's electrons can get through to the other side. If the base is in a generous mood, it allows a lot of electrons to pass. If it's feeling a bit stingy, it restricts the flow. This control is what makes the transistor such a crucial player in electronics. Finally, we come to the collector. As the name suggests, it's there to collect. It's the final destination for the electrons that have made it past the base. It's like the city that all the train station's passengers are trying to get to. So, let's put it all together. When a small current is applied to the base, it controls the number of electrons that can pass from the emitter to the collector. In other words, a small input current can control a much larger output current. This is why transistors are used as amplifiers. But that's not all. Transistors can also act as switches. When no current is applied to the base, the transistor is off. Apply a current and it switches on, allowing a larger current to flow from the emitter to the collector. In essence, the transistor is a miniature switch that controls the flow of electricity, making all our digital devices possible. From the first transistor radio to the powerful smartphones in our pockets, transistors have come a long way. These tiny powerhouses are the unsung heroes of our digital age, silently working behind the scenes in virtually every piece of modern technology. Over the years, transistors have evolved, shrinking in size while exponentially increasing in power. This miniaturization has allowed for the creation of microprocessors and microchips, the brain and backbone of any digital device. In the realm of computing, transistors are the binary code writers, flipping between 0 and 1, creating the digital language that our devices understand. In telecommunications, they amplify and switch signals, allowing us to connect and communicate across the globe. Even in space exploration, transistors play a pivotal role. They are part of the advanced technologies that power our satellites, enabling us to reach beyond our own planet. So next time you use your phone, remember the tiny transistors that make it all possible. Without them, our digital world as we know it would cease to exist.